C. Murali. I am from CSMB. Today I am here to tell about molecular orbital theory. Introduction to molecular orbital theory. Molecular orbital theory explains how atomic orbitals combine to form molecular orbitals in a molecule. It provides a detailed understanding of bond formation, strength, and properties of molecules. The theory constructs with valency bond theory by focusing on electrons in molecular orbitals rather than localized bonds. Basic principles of molecular orbital theory. Atomic orbitals combine constructively and destructively to form bonding and anti-bonding molecular orbitals. Electrons are filled into molecular orbitals following the Pauli exclusive principle and Hund's rule. The overall stability of molecule depends on difference between the number of electrons in bonding and anti-bonding orbitals. Formation of molecular orbitals. When two atomic orbitals overlap, they form a bonding molecular orbital with lower energy. Simultaneously, an anti-bonding molecular orbital with higher energy is formed. The energy and type of orbitals formed depend on the symmetry and energy of the original atomic orbitals. Molecular orbital diagrams. Molecular orbital diagrams visually represent the energy levels of molecular orbitals derived from atomic orbitals. For diatomic molecules, these diagrams show the relative energies of bonding and anti-bonding orbitals. Electron filling in these diagrams helps predict magnetic and bonding properties of molecules. Bond energy and stability. Bond order is calculated as half on difference between the number of electrons in bonding and anti-bonding orbitals. A higher bond order indicates a stronger, more stable chemical bond. Molecules with a bond order of 0 are typically unstable or do not exist as stable molecules. Application to homonuclear diatomic molecules. Molecular orbital theory is particularly useful for understanding diatomic molecules like O2, N2, and F2. For example, O2 has two unpaired electrons in anti-bonding orbitals, explaining its paramagnetism. The theory accurately predicts bond lines, bond energies, and magnetic properties of these molecules. Electron configuration in molecular orbitals. Electron configuration in molecules is written by filling molecular orbitals in order of increasing energy. The total number of electrons from atomic orbitals determines the filling pattern. Electron configuration helps predict whether a molecule is paramagnetic or dimagnetic. Limitations of molecular orbital theory. Molecular orbital theory can be complex for larger molecules due to increased number of atomic orbitals involved. It often requires computationally methods for accurate predictions in polyatomic molecules. The theory does not always account for electron correlation effects which may influence bond properties. Summary of key points. Molecular orbital theory forms a comprehensive framework for understanding chemical bonding. It emphasizes the importance of molecular orbitals and electron distribution over localized bonds. The theory is instrumental in explaining phenomena like paramagnetism and bond order variations in molecules. Reference Atkins, P. and D. E. Pauli to J 2020 Physical Chemistry Oxford University Press. Levin in 2014 Quantum Chemistry Person Education. Cotton F. A. Millikan G. 1999, Basic Inorganic Chemistry, Wiley Inter Science. Thank you.